Welcome back to the Garage to Apartment Conversion series. In this episode, we're going to be doing some electrical work.
So what I typically do is...
Okay, before I start off too far ahead, you might have noticed there are already electrical boxes installed. Dad did that off camera. So let me go back and explain some things about that hopefully someone will find helpful. The first thing we do when wiring is plan where all of the boxes will go. Switch boxes, ceiling boxes, receptacle boxes. A drawing would be ideal, but if you're lazy or pressed for time, you can plan the boxes on the fly. Just grab a marker or crayon, walk through each room, and directly on the studs mark the best spot for light switches and receptacles. And if you can reach the ceiling joists, you can mark the ceiling boxes too. When you get everything roughly where you'd like it, go back and make sure you're following the electrical code on where receptacles may go in kitchens and bathrooms, and where dedicated receptacles go, like for refrigerators, microwaves, washing machines, etc., and make adjustments. Then you can go back with a measuring tape and mark the proper height of all the boxes. The standard height for wall outlets is 12 inches from the finished floor to the bottom of the box, and they're spaced so that you can reach any outlet in the room with a 6-foot cord. There should be an outlet within 6 feet of any corner or obstruction, and no more than 12 feet apart on a clear span of wall. But there's no limit to the number you may install. I like to put one about every 6 feet. Switch boxes are usually around 48 inches from the floor. Once everything is marked, grab a bucket of boxes and start nailing them in place. Now back to whatever I was rambling on about.
So what I typically do is I look at how the receptacles are laid out, and I just go the shortest and easiest way. So it looks like from here, the wire will be secured right here, and I'll just go through stud, through the stud, through the stud, into this box, across here, secured there, up to this box, out, into this box, secured here, on here, through here, secured here. Actually, that's the bathroom switch. We don't even need to worry about that. So we'll just keep running through here until we get to this box over here. And after this box, what I'll do is go up and through there to the panel. Here's where we run into a tricky bit. So I need to drill through here, through here, and so on. And I can't get my drill in here. And even if I put a little right angle attachment on here, it'd still be hard to get the bit in between these right here. So what I'm going to do is actually, since this won't reach all the way to the next one, I'm going to put an extension on this. And another cool thing about these is they're actually kind of shorty bits. So when you get in a tight space, as you'll see here, you can see that drill just fits in between there. Also, as I'm going from this box up through this blocking to get up and out of here, I'm going to drill about over here to make sure I don't drill through the nails that are obviously going through here. So that's another thing you sometimes learn the hard way. So swoop it out a little bit and then go back in. Panel I need to get to is way down there, and I'm going to be running multiple circuits to it, so I'm going to go bigger than this. I'm going to put a fairly big hole somewhere in here so I can get several wires through it and down to the box. Let's see if we got a pretty big bit. 15/16. See if we get something bigger. Oh, look at that. 1 1/4. Let's try that. So what I've done is made a slightly curved hole. So we might be able to get one more wire in there, but why waste the time when we got to pull several more? So I'm just going to go ahead and do another big 1 1/4 hole right through there. Now let's drill for the dedicated bathroom circuit. So here's the switch. This is going to be a bigger box. We're going to put a double box in here. But since power has to come to the switch first, it doesn't have to, but it's definitely preferred. We'll bring the power in from the top of the wall through the attic space down there, and then out again into where the light fixture and fan are going to be, and then of course over to the ground fault receptacle, the box of which we haven't put in yet, so we'll put it in over there somewhere. Okay, so I think we got most of our holes drilled. So now it's time to start pulling wire. Really quick before we go much further, I'm going to explain how we do our circuits. We tend to run 12 gauge wire to our receptacles, and we put that on 20 amp breakers. And then we'll run our lighting circuit separately, and we'll put that on a 15 amp breaker and use 14 gauge wire. So we'll use 12 gauge wire for all the receptacles on a 20 amp circuit, and 14 gauge wire for all the lights on a 15 amp circuit.
We staple the cable at least every 4 feet and within 12 inches of each box. This box will need to house separate switches for the lights and exhaust fan here in the bathroom. Though this is doable in a single gang box, it's much easier in a double gang. The boxes have these spacers to make them protrude into the drywall cutouts. I'm always double checking to make sure the switches within each room are a consistent height. If we nail this box here, it will look too close to the end of the wall. We need to pad it out. When you drive a screw through two pieces of wood without a pilot hole, it almost always pushes them apart, because it takes a second for the screw to bite into the second board, but it's still moving through the first one. If you back it out and drive it in a second time, it fixes the issue. Here I'm measuring the room so that we can center the ceiling box where we'll eventually have a ceiling fan. Now we'll start the wiring runs for the three-way switches that will operate the ceiling fan. Here's the other of the two switch boxes. We're using 3 conductor wires since these will be three-way switches. For a more detailed how-to video on three-way switches, check out the card in the corner, or look for the link in the description. We've decided the switch should not go over there, but should go right here, so that when you come in with your hand on the knob opening this way, you can reach your other hand and turn this off while you close the door, or turn it on, excuse me. So I don't think that hole is big enough. I have to make another one. These connectors keep the wires from getting pulled out of the box. We're upsizing this box also, so that we can add a switch for some exterior sconces. I use a masonry bit to drill through this hardy plank. The router makes a recess for cable. This will get covered by nailing plates before the drywall goes on. We put blocking behind where the exterior wall sconces will go.
So close.
This is where a TV was going to mount, but we're moving it over here. This ceiling box is for when you need a light exactly in the center of a joist. Here's basically how it will look when we get it up there. The switch that operated this outlet will now operate the light that will go here. Now we need to run wiring for the washer and dryer. you're like me, the funnest part of construction is getting to be a kid on a jungle gym again. We need some blocking for the dryer outlet. Wiring needs to be protected from screws and nails by these metal plates. Dad ended up wiring the breakers off camera. Sorry about that, but if you want to see how that's done, I'll include a link to another video I did on that in the description below. Here Dad is wiring the switches. This was supposed to be more instructional, but it accidentally got time-lapsed. Well, that's about all we need to do to get us through our electrical roughing inspection. As always, thanks for watching, and we hope to see y'all in the next one.